Hello dear viewers, welcome to our channel. In this video, we will not be doing any board repairs, but I will share information with you that is just as important as board repair. The topic of our video is the common mistakes we make in electronic repair. I will explain what these mistakes are. Perhaps you might be making these mistakes as well. Before I begin my video, let us not forget to subscribe and like the video to help our channel grow so that our channel can reach a better place and appeal to more people. Videos need to be liked and commented on. Friends, I hope our channel goes to great places. With your help, thank you in advance. Let us start our video. Our first mistake is not starting with knowledge, with electricity. We need to start with knowledge. We need to know the basics of electronics, friends, and we need to know how the board works. We need to know at what voltage the board operates. One of the most common mistakes is attempting a repair without knowing anything about the board. You need to know what the board you are holding does and what voltage it operates at. You need to know which components are critical and which ones are more prone to wear.
So, it is difficult to start a repair without knowing these. And you end up attempting a difficult repair on a board you do not know.
What's the solution? Try to understand the board's operating principle well. You need to know where the energy comes from, where it drops or where it multiplies, and what these components do. Friends, another mistake of ours. You have a board in your hand or you are working on a repair job. They brought you the board is not working. You need to ask what happened to this board or what was being done when it happened, meaning what caused it to stop working. You need to know what the board has been through. They bring you the board, it doesn't work, but what exactly is not working? You need to know and ask if it has no power at all or if a specific function is failing. Otherwise, the hardest repair is the one you do without knowing anything about board. Asking these questions during board repair will be very useful for you. Another mistake is when you look directly at the board. For example, let's say this component here has turned black. I am not talking about punctures or things like that. It may be blackened or dusty over time. Do not rush to replace it, friends. First, measure it properly. If necessary, remove it from the circuit and be sure, do not start with a replacement right away.
This is also one of the frequently made mistakes.
Speaking of replacing parts, another common mistake is, for example, if this component here is faulty. If a MOSFET, transistor, or integrated circuit is dead, when ordering them, do not order just one, order 3. If you ask why, one is for testing, the other is for trial, and the third is a spare. If you do this, you will not have any trouble. Friends, this is my tactic. I always buy at least 3. Because anything can happen. You might install it incorrectly. It is human nature. It could blow up. You use the second ones to compensate for your mistake. The third one will be your spare. Another mistake is starting repairs without using a series bulb circuit. You can use a series bulb for 220 volts, sure, but you can also use series bulbs for 12 or 24 volts as well. Because a mistake you make can cause the entire board to stop working. A short circuit can ruin the whole board, but if you use a series bulb, you protect the board and you also protect your system. You will have protected yourself in the event of a direct short circuit instead of an explosion. Only the bulb lights up and alerts you and no damage occurs. Neither the board gets damaged, nor do you get hurt. So pay attention to this. Even if you are doing this as a hobby, I strongly recommend that you build this series bulb circuit at home. Another mistake made is applying the wrong voltage or too much current when testing or powering a board, which can damage it. For example, you might have a 110 volt board. You apply 220 volts to it, this board could get damaged. Or you apply 12 volts instead of 5 volts and that part could get damaged. So you need to pay attention to this. Think twice when testing, friends. Do not rush.
Electronics do not like this rust.
Another mistake made is on sensitive boards like this, on boards with sensitive components like these, starting repairs without using an anti-static wristband. These processors operate on 1 or 3 volts. Since these processors transfer static electricity from your body to the board, they can damage them. Let me show you. You can discharge yourself by connecting the other end of an anti-static wristband to the ground. In fact, when boards go for repair or when you buy a new one, they come in an anti-static bag, meaning ESD. This stands for electrostatic discharge. So the static electricity in our bodies can damage these cards. Do not say nothing will happen because of this. Maybe many cars failed without you even knowing. The microprocessor died. You never know, so take your precautions for such sensitive cards, whether it is a graphics card, a motherboard, or RAM.
Definitely take your precautions, take your precautions.
Another mistake is using low quality materials, especially solder wire. It would be better for you to use a 6337 thin lead mixture solder wire. Furthermore, you must use flux when removing surface mount device components, because flux softens the solder and makes it easier to remove. When desoldering such surface mount device parts, small surface mount device parts, you must insulate the surrounding area with heat-resistant tape, because when you apply the hot air gun, the components there might fly off, so you need to pay attention to this.
So focus on using quality materials, because poor quality materials will turn an electronics enthusiast away from electronics. This is clear and certain. You can try it for free.
Let me show you. You can put this flux into a syringe like this and apply a small amount around the component you want to remove. This will soften the solder there and it will come off easily.
Small microprocessors.
You can use this cream solder for soldering. It melts at 180 degrees. You can very easily solder SMD components.
You can solder, you can assemble it.
Another mistake that is made is,
For example, let's say
Over here.
Let's say our integrated circuit blew up or burned out. Do not focus directly on the visible fault. Why did this component burn? Why did it end up like this? Measure the surrounding components as well. I mean, you need to think about this. If you just replace it directly, you would be focused on the solution, not the result. You would not be focused on the solution. You would be focused directly on the result. Sorry. So check the surrounding components as well. Why did this failure occur? This part burned, but why? You need to find the root cause. Otherwise, it will not be a successful repair. It will fail again, and it will just keep going like that.
The important thing is to focus on the solution, not the result.
Yeah, not a mistake, mate. Let's say a board arrived. You are dealing with repair work. You measured and analyzed it. You found the error very nicely. What if something goes wrong? A photo, but there is no photo, there is no going back. Or you installed the integrated circuit backwards, or you were in doubt. There is no turning back from that. You absolutely must take a photo. Integrated circuits have an orientation. Other things have an orientation. You must take a photo, because then you will try to find the same board again. You will search the whole internet for it. So
No matter what kind of board it is, definitely take a photo of it. Everything has an orientation. It could be a tantalum capacitor or a diode. You never know the orientation.
My humble advice is to always take a photo.
Guarantee your work.
Another mistake made is not using a compatible equivalent part. You cannot just install any component here just because it has the same pins. That component, you must check its datasheet to know how many volts it operates at and how many amperes it can withstand. By checking this, you can find a compatible part. But let's say this MOSFET is broken. You cannot just install any MOSFET here. That is another common mistake. You must choose a compatible replacement carefully. It might not be the exact same one. You can find a substitute, but its amperage, voltage, and other specs must match by checking the datasheet. This is very important. Otherwise, the board might work for a moment, but it will fail after a while.
The component there will get damaged again, or it might damage other components as well. We must be very careful about this. After the repair is finished, we need to test the board properly. Are the components heating up? Sometimes it might work at that moment. Do not just say, no, see, until it works, let me turn it off. Check if the components there are heating up. In other words, play it safe. As I said before, play it safe. Electronics work requires patience and curiosity. So you need to be careful. Think twice when fixing a fault. Protect both yourself and the board. If you have anything else to add or other mistakes that are made, you can add them in the comments section. Other friends can learn from them too. If there is anything you want to ask, feel free to ask. Thank you for watching the video. Goodbye.